When conducting an experiment, one of the things you're doing is collecting data. And oftentimes you collect your data into a data table. Well, when you have a data table, you just look at it like this. It's not as meaningful to the reader as if you put it in a graphic representation, which is why we make graphs. Now, when you're making a graph, there's several things that you need to consider because we're comparing variables here. Well, where do you put the variables? Well, we have two types of variables. One is called an independent variable, and the other is called a dependent variable. The independent variable will invariably be put on the x-axis, and the dependent variable will be put on the y. So what's the big difference? Well, the independent variable is under the control of the researcher. It's the cause. The dependent variable is the effect. It's your results. You can keep in mind that independent causes change in the dependent. So if we're looking at our data set here, we have age and we have height. Now the age is under the control of the researcher. The researcher is looking at different age kiddos, and over different ages, that height changes. So the independent for this case is age, and the dependent is height. Now when you're making a graph, you have to label those axes appropriately. So since age is our independent, it will go here. Now, is that age in months, age in days, or age in years, minutes? What is it? So you have to be very careful that you don't forget to include your units of measure. For this example, we'll say it's age in years. Now we can put our dependent variable, which is height, along our y-axis. And once again, we have to include our unit of measure here. Is this centimeters? Is it inches? Is it feet? Well, for our purpose today, we'll just say it's inches. And then you have to label the bars that are in the graph. And usually you just look at your data and see what would work most easily for your graph. So let's say we've got 1 year, age 2 here, age 3 here, age 4, and age 5. You can keep going. Even though it's not in the data, we can still continue our graph. And then we do the same thing with height. I see here that we've got increments of 10, and then there's a 5 thrown in there somewhere. So I'm going to start with 10 here, and just go up and skip a line to represent a 5. Alrighty. And then we can go ahead and plot our data points. So at age 1, the height was 20 inches. I just put my data point. At age 2, 30. At age 3, oops, I messed up, didn't I? Let me go back. At age 2, it was 30, right there. At age 3, it was 40. I also highly recommend when you draw a graph, you use pencil, because you will probably make a little boo-boo just like I did. 45. At 5 years, we went up to 50. Alright, and we're making a nice little curved line. Now, we need to give our graph a title, and you just give it a title that describes what the graph is about. So we could just say height over time. It doesn't want to write. Of course, yours will look a lot neater than mine does. Now, another question that always comes up, how did you know to do a line graph? Well, you want to use a line graph when you're using continuous data. See how we have age along our independent, axes, our x-axes. That's a definite change over time. There's a continuous change in height as a person gets older. Why not use a bar graph? Well, a bar graph works best for category data. So let's say that we were comparing not a continuous change of height in age over years, but let's say maybe we were just comparing the height of males and females. A bar graph would be a better representation here because we're comparing two different categories, males and females.